Hey, hi guys, this is Faizan and welcome to today's session on data structures and algorithms in Java. So before I start, can you guys quickly confirm in the chat if I'm audible or not? Is everything okay? Can you see me? Can you see the slide deck? And can you see the pointer that is over here? If yes, if everything is okay, then give me a quick confirmation in the chat and then we can get started, okay? And in the meanwhile, let me give you a quick tour of how our academy looks like and how you can register to our free courses and get your certificate of completion. Okay, so this is the Great Learning Academy. You just type in your browser Great Learning Academy. The first link that is there, it will redirect you to this page. And here you can see different options. So if you're looking for a career path and you want to know how to get started in software development, just click on IT and software, and we have over here we have three options: software developer, front-end developer, and information security engineer. Similarly, we have different options for data science, artificial intelligence, machine learning, cloud computing. Okay, and if you're looking for a career transformation programs, just click on it, and these are the different programs, and you can see the top ranked programs of ours. And if you're looking specific to software development, you can just click on it, and you have these PG courses that are available. So we have the courses where Triple ITH Hyderabad, and we have IIT Madras, okay, and we also have a MCA degree program, okay. So if you're looking for something which is absolutely free, just scroll down, and these are the popular courses that we have on our academy, and these are absolutely free. You don't have to pay anything, and in order to get the completion certificate, you just have to register yourself and go through the course, enroll for here. For you can over here you can enroll it, click on any course, okay, and then these are the skills that will be covered, and this is the whole syllabus of this course, and plus the completion certificate will look like this with your name on it, okay. So you can add these in your resumes and in your LinkedIn profiles, okay. And if you're looking for courses that are specific to IT and software, right? So you can just click over here on IT and software, and these are the courses that are there. We have CSS, HTML, blockchain, data structures in C, Excel for beginners, Android application development. Oops is there. We have some games in JavaScript, in Java. We have introduction to JavaScript. All of these courses are absolutely free. Okay. And if you're looking for something which is in Hindi, right? The language you are comfortable in is Hindi. Have your courses in Hindi as well. We have different courses. Okay, we have Java, React, C, C++. All of these are absolutely free. Okay, so now these are all free courses dynamic. Okay, and if you're looking for live sessions like this and you want to know when is when is the next live session and who is taking it, you can check it over here. Okay, you see over here on today I'm taking data structure and algorithms. Today we have today itself we have on 5:30 to 6:30 we have interview etiquettes. Okay. Then there's a career designs, data science and AI, right? So this is on Saturday, and you can view all the live sessions over here just by clicking on this view all live sessions. Okay, without any further delay, let's get started with our session. Okay, okay, I can see some yeses. Okay, great. Okay, Sajan says I'm from Nepal. Hi, Sajan. Thanks for joining. And let's get started. Okay, so these are the things that we are going to cover in this session. So, first, we are going to talk about what is Java, then what is data structure, then we are going to talk about simple data structures like arrays, then linked list, and then stack. Now, this is a 1 hour session. We cannot cover that much over here. So, these are three data structures that we are going to talk about, and then the algorithms that are there. We are going to talk about searching algorithm and one sorting algorithm. Okay, so this is just to give you a head start over learning all these data structures and algorithms. Okay, so the language we are choosing is Java. Now, why we are choosing Java? Because it is a object oriented programming language. It is a high level language which was originally developed by Sun Microsystem. Okay, so now this is something with the help of its JVM. If you want to know in detail about Java, we have courses available in Hindi as well as in English. Let me give you a brief overview over here. So basically, why we are choosing Java? Because it is a language with the help of its JVM, the virtual machine. Java is platform independent. Okay, thus making it easier for most of us to use. Okay, and it is very simple and very easy to understand. You just want, if you want to get started in Java, you just have to maybe some basics of C, just to, because all the programming constructs like while loop or if else will be same, there will be not much variation. Okay, so a little bit of C and something that is related to C++, because it will give you some correlation. You can correlate that C++ with Java. Okay, if you don't have any understanding about these two languages, it's okay. Okay, because C++ is an object-oriented programming language, whereas C is not. So, but Java follows this object-oriented paradigm. So that is why I'm talking about these two languages specifically. Okay, so C and C++. If you have some idea, it is easy to understand Java. Okay, so I'm continuously monitoring your chat. If I'm looking on this side, that means I'm monitoring your chat. If you have any questions, you can put them in your chat box and I will definitely answer them. Okay. If okay, volume is volume okay, Raj? I hope volume is okay now. Okay, cool. So now it follows a principle of Vora. That means write once, run anywhere. That means you can run your programs on any Java supported platform. Okay, so you have one program and you went on your friend's system and that Java is already installed in it. So you don't have to, once it is compiled, you don't have to, you can just go with the exe file, the executable file, and run it over there. You don't have to compile it over and over again. That's the beauty of using Java. So this is a gist or summary, or you can say a brief overview of Java. Now let's quickly understand what is a data structure. We have courses, so don't worry about it. If you want to understand more about Java, it's okay. We have courses on our Great Learning Academy. You can register to them. Okay. And now let's talk about data structure. Now, as you can see over here, you can easily see that there are two words in it. One is data and another is structure. So how you are structuring your data. Now, obviously, when now data is important, right? Anything that you are storing, and once you are able to understand how it is structured in your memory, then you can easily get out, or you can understand the time and space complexity of that particular data structure. So that is why these data structures are important. When you know how it is stored in your memory, then only, let's suppose you are using arrays. Now you want to fetch some element. Now, obviously, in worst case, now that means worst case, that the element that you're trying to find is present at the end. Now, if you know you are using the array data structure, then you can easily understand, okay, the time that I will require to find that element will be order of n. That means all the elements that are present in that array, I need to traverse them one by one. So this is very important, right? How you are structuring your data in the memory. So that is why you will learn about these data structures. So in order to make your programs or make your applications much more efficient, simple as that. Okay, it is a way to arrange your data in computers, and you might want to store your data. Now, there are two different ways with which you can store your data. One is in linear fashion, another is in hierarchical fashion, or you can say non-linear fashion. So when you're storing your data in a linear fashion, that means here arrays, linked list, your stacks, your queues come into picture. Okay, and now if you're using some different data structure wherein the data is stored in an hierarchical order, therein you will have these graphs. Okay, trees. Okay, all of these will come under that domain. Okay, so now let's start with the simplest data structure that is out there, and most of the questions, right, in most of the companies, the questions will be around this. Okay, if you're not going for tech giants, then most of the companies will ask questions that are related to arrays. So what is an array? Let's try to understand it. So it is a linear data structure. That means your data will be stored in a linear fashion. Okay, now, when you are storing your data in a linear fashion, that means if one element is over here, the next element will be in the contiguous memory location. That means if, let's suppose, for simplicity, I am making this address as 100, right? Because I know it will be a hexadecimal number, but for simplicity, I'm taking this number as 100. Now, if this is 100, the next memory allocation, that means contiguous memory allocation, the next element in the array will be stored at 104. Okay, considering the size of int is 4 bytes. Now the second is 108, then 1012. Okay, 1112. So this is what do you mean by contiguous memory allocation. And now in order to access any element, there are indexes. Okay, 0, 1, 2, 3. The indexes are there so that you can easily use those indexes to access any element that is present in this array. Now, one more thing, when you're storing these elements in your array, it has to be homogeneous element. That means similar. So that means if your data type is, that means which type of data you're storing in your array. If it is an integer, then you can only store integer data. If it is a float, you can only store floating point numbers, right? If it is a character, you can only store characters. Okay. So similarly, you can store similar type of data. Okay. Is this thing clear? Most demanding video. Okay, okay, sure. So, Roshan, I have already taken sessions on competitive programming, and there is a series, right? 1 to 8 on competitive programming. I have covered no, different data structures and algorithms in that series. You can check it out. Okay, that is already there. That is specific to competitive programming, and in order, if you have some, or if you have a programming knowledge, a little bit of programming knowledge, you can easily go through those sessions and get started get started in solving questions. You can easily solve questions on lead code or on geeks for geeks. Okay, it's better to go for lead code. Okay, perfect. Can you guys quickly confirm, is everything clear until this point? Can you understand each and everything? If yes, just quickly give me a confirmation in the chat. Just write a quick yes. If you want me to repeat anything, obviously I'm going to repeat it. Okay. So there's a series. Okay, Prashant. Okay. Okay, Roshan. Roshan was asking this. Okay, Roshan. So there's a series on competitive programming. Around 8 sessions are there on our YouTube channel. So you can check them out one by one. Okay, I've covered different heaps is there. I think stack is there, heap is there, priority queues are there. Mm, a lot of things that I have covered: stacks, queues, arrays, strings. Okay, you can check them. Cool. How to implement data structure in Java? That is what we are trying to understand. There are different data structures, Manish. Okay. There are different data structures, and we will try to implement one by one those data structures. Okay. Cool. So now how do you declare this array? Okay. So for declaration, you have to obviously use this data type that helps us to understand which is the data that you're trying to store, which type of data you're trying to store in your memory, then the name of that array. And then with the help of new keyword, you're allocating memory. Then again, you have to specify the data type and then the size, how many elements are there in your array. Okay, or you can go for this declaration as well. The brackets in this Java, you can have your brackets in front, or you can have it in front or on the back side. Okay, so this is the array declaration, and you can easily declare and initialize your array. You just have to write int, then the name of the array. Let's suppose ARR, then these uh, indices over here, that this says that this is a 1D array, and then elements, let's suppose 1, 2, 3, 4, and this is how you declare and initialize your array. Okay, now you might be thinking, what are the advantages of using this array? Why should we go for arrays? So basically, one is that you have these indexes, right? 1, 2, 3, that is given on your array, right? 1, 2, 3. So you can easily, with the help of these indexes, you can easily find out, okay, this is the location. If I'm trying to access ARR of 0 or ARR of 4, that means I'm going to access this fourth location, right? So that means this fourth means that this is the fifth location, or let me just write 3, because indexing starts from 0. So if I'm saying 3, that means the fourth element in the array. Okay, 1, 2, 3, 4. Okay, cool. Now, can anyone tell me why, which programming language is best for data structures and algorithms? Is completely dependent on you. If you're familiar with some language, I will suggest not to change your language. Maybe in C, it might be complicated to implement all those data structures. The code will be lengthy, but yeah, I don't want you to change your language. But if you want to go for competitive programming at that time, if you are in third year or fourth year, it's rather to stick the language. Obviously, you should be using either Java or C++. Now, if you know Java, well and good. If you don't know any of these and you are still in your first or second year, better to go for C++, because that when you're going for competitive programming at that time, C++ is much more faster as compared to Java. Okay. So now quickly, why indexing starts from zero? Is there any logic or is just for the sake of simplicity? So indexing starts from sorry. So indexing starts from zero because, as you know, the name of the array depicts the. Let me just write it. The name of the array depicts its base address. Now, once you have that base address, now anything that is when we talk about this base address, that means this is 100. So this is the base address of this array. So now when I say ARR of 1 or ARR of 0, that means what I'm doing an arithmetic, or you say the reference, I'm adding this reference, or I'm adding the number of bytes that are there at that particular location. So 100 plus 0 gives me 100 again. That means I'm pointing to the first location. Then 100 plus 1. Now this 1 represents the number of bytes of integer. Okay. So there are, now it means that 100 plus 4, that means 104. I am going for the second location. Now 100, or you can say that ARR of 2 means 100 plus 8. Okay, number of bytes. Okay, or you can say, for simplicity, you can say that whatever is the index multiplied by the size of, size, or the data type size, whatever is the data type multiplied by that size. Okay, plus the ARR, that means the base address. Okay, so that is why your indexing starts from 0. So if I say ARR of 1, it means ARR plus, that means it represents the base address. Okay. Sir, Java is used in backend in web development. Yes, yes, you can use it. Okay. In the backend, but if right now Java is not that much used, if you want to, if you have any idea, or if you have some understanding of what, you can say, no JavaScript, then you can easily, in your front end you can use your React, and in the backend you can use Node.js. Okay, and most of the companies are shifting to Node.js. Now, ARR is equivalent to size into the data type, or you can say the size of data type multiplied by the index. Now, what is the index? 1. Size of integer is 4 plus ARR represents the base address, that means 104. Okay. Similarly, if ARR 0 I'm talking about, so it means 4 into 0, which is again 0, plus 100, which is again 100. Okay. So this is why your indexing starts from 0. I hope this is clear, Pratik. Okay. I have explained it again. Okay. So that is the reason why indexing starts from 0. Now, with the help of this indexing, random access is possible. That means if I know, yeah, Shalini, do you want me to repeat this again? If yes, then write it again. Okay, I explained it again. Okay, so yes, so if you know the index, then you can easily directly go to that particular index and fetch the value. Okay, okay. Now it's easy to sort and iterate through this array. So obviously, when I know this particular, how I can go through this particular array, I know the indexing starts from 0, and I can easily, with the help of this indexing, I can play around it. Sir, I am in class 11th. Is that? Yes, 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 Sabah. Okay, you can easily go through this session, and you can just learn it. Okay, so it will cover your basics, and then maybe in future, if you want to understand, if you want to go into the computer science domain, then you can easily go through this session, and you can easily have some kind of idea regarding data structures and algorithms. Okay, so now, what is this replacement of multiple variables? Now, prior to this array, okay, prior to this array, if I want to store the name of 5 students. Okay, 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 great, 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 guys, keep interacting, guys. Okay, if if I want to store the name of, or I want to store the roll number of 5 students. Now, what I if I don't know this array data structure, what I have to do is that I will write int roll number 1 equal to 5, or roll number equal to, or you can say student 1 is if I have 10 students, I will write student 1 roll number is 5, student 2 roll number is 10. And similarly, if I have 50 students, I am going to use these many variables, right? Now, what do you mean by this replacement of multiple variables? As you can see, there are multiple variables over here, right? Now, I don't know the array concept. Now, once I know the array concept, what I can do, I can create one array of students, and the size I can change it. I can say that the new int of student is 50. The size is 50. That means I can store 50 roll numbers in this array. Okay. Also, I can name this array much more elegantly student roll number array. Okay. So I can easily store all of those roll numbers. Now, instead of going for 50 variables, now the requirement changed. Okay. Now, after maybe 1 year or so, the requirement changed. Now I have 100 students. Instead of going again and declaring those 50 more variables, I can easily update this to 100. Okay. Or even much more simpler way can be this. I can make it dynamic. That means I will ask the user every time if there is an updation required. I can change this size of the array. Obviously, I need to copy then these elements in a different array. Okay, that can be also done. Okay. We have courses above. We have courses on our academy, also on our YouTube channel. There are different. Uh, will you complete DSA? Not in this session, but we have Fahim. We have courses available on our academy and on our YouTube channel. You can go through them. Okay. Sabah, we have courses on AI on our academy as well as on our YouTube channel. You can go through it. Okay. Or if you're looking for something which is much more advanced, then we have also PG courses available. Okay. Now, this is what you mean by replacement of multiple variables. Now, what are the drawbacks? So you can easily think of the drawbacks is that the size is fixed. That means if you have this 5 over here, that means this is the number of elements that can be stored in an array. You cannot store 10. The size is fixed. Okay. So this is not possible in arrays. Is there a way with which we can avoid this thing? Yes, for that we have linked list. The next thing we are going to talk about is linked list. Okay, so it is difficult to insert and delete. Now, why do you think so? It is difficult, and it is deleting an element and inserting an element is difficult. Let's suppose this is an array, and this is the element that you want to delete, or you want to insert any element over here. Now, over here there will be already element, right? There will be already an element. Now, for insertion, the first thing is that you need to have an extra space so that you can insert your fifth element. But what happens if your space is available and you want to insert an element at this particular location? You need to swap these variables one to on the right hand side so that you can insert 5 or 6, whatever you want to insert. That means swapping is required. Similarly, when you want to delete this element, again the swapping is required. Else there will be a zero value, or there will be no element that is valuable to you, or you are exhausting your space unnecessarily. So you need to swap those things. Okay, that is why what is meant by difficult insertion and deletion. Now, if your occupancy is less, right? If your occupancy is less, but your capacity is more, that means you have unnecessarily declared your array of size 100, but you are only storing two elements in it. So that means 98 into 4, these many bytes, that means 8 into 4 is 32, 9 into 4 is 36, and this means around 392 bytes of memory you are wasting. Okay, you are wasting this much memory. Okay, so it doesn't make any sense. So that is what you mean by wasting your memory. Or if your occupancy is less and you want to insert, or if your occupancy. Guys, can you hear me? Just quickly confirm. Just write a yes. So sorry for this, as my system crashed. And please quickly give me a confirmation that you guys can hear me so that we can get this session going. Just quickly write a yes or no. Okay, so now, okay, great. So now we were talking about, sorry, we were talking about that why. Okay, okay, great, 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 great. So now we are talking about the occupancy, right? If the occupancy is less and we are trying to store more elements, that means uh, we are wasting some amount of memory, right? But there is one more problem. Let's suppose this is your memory and you're trying to insert your elements, and you have a specific chunks of memory available. Let's suppose you have over here, you have 4 bytes of memory. Over here you have 8 bytes of memory available, and over here you have 4 bytes again. Okay, rest of the memory is full. It's a hypothetical situation, guys. Okay, now what happens when you're trying to store elements in a contiguous memory allocation? That means the size of your array, let's suppose how many elements we require is 4. The size of the array is 4, 0, 1, 2, 3, 4. And now it requires a contiguous memory allocation, and you require 4 into 4, 16 bytes, right? And those bytes should be contiguous, but you have 8 bytes over here, 4 over here, 4 over here. You have a total of 16 bytes available, but you cannot store these elements. Why? Because they are available in different chunks. Okay, so that is the whole point of having this contiguous memory allocation. You are underutilizing your memory. Okay, is this thing clear, guys? So you are underutilizing, although you have your memory available here and there, but still your you cannot store your elements. So that is the whole point of getting this contiguous memory allocation. But is there a way that we can avoid this mess, these disadvantages, right? What are the disadvantages? Size, occupancy, and contiguous memory allocation. Can we avoid these things? Yes, with the help of linked list. This is why linked list came into picture, and this is why we were trying to understand what arrays. Okay, is it same for all of you guys? Can you guys hear me? Harsh is saying, Priya is saying that I cannot, she cannot hear me. I'm not audible. So quickly, guys, can you confirm if I'm audible or not? Is this happening for everyone? Okay. So this is a small demonstration. So here we are just declaring an array, right? So we are importing this because we are using different, this is a package that we are importing because we are using a scanner class over here. Okay. This is the driver function. This is the name of the class. And this is okay, so this is the loop for which, with the help of which we are inserting elements in our array. Here is the declaration of the array, and here we are inserting the elements. Then we are just simply printing out those elements. That's it. Okay, is it done? Okay, okay, great, great. Now array is a very simple data structure. Okay, now why we were trying to understand this array as a data structure, because we want to understand the drawbacks that were there before linked list. Now the second thing that is there is linked list. Now what is a linked list? It is again a linear data structure like array, but the memory availability, right? As let me give you that memory diagram again over here. Okay, so you have 4 bytes over here, you have 8 bytes over here, you have 4 bytes over here. In array you cannot store your all the 4 elements, right? But in linked list you can store those elements in this. That means you are utilizing your memory as per the availability. Okay, if the memory is available, you can utilize it. Now elements can be accessed in a linear fashion. Now what do you mean by this thing? There are nodes. There's a term called as node. Now what is this node? This is nothing but it contains two data parts, right? There is one part is where you store your data, the second part is where you store the reference. Now if we are talking about this particular, the first node, it is also known as the head node, right? And you, no matter what happens, you should not lose your head node. It is referred to as head node, and this is where, with the help of which you can traverse this whole linked list. Okay, now I am reiterating what I said. Okay, let me just refresh this. So there are two parts. One is the data part and another is the reference. Again, there is second node, this first node, this second node. Okay. Again, you have the data where you store your data. Let's suppose 5 element value what you're trying to store. 6 you're storing over here. Now what this reference contains, for simplicity, let's suppose the address of this is 2000. Now this will hold this 2000. Okay. And this is also known as the head node. Okay. This is very important. It is with the help of this head node you can traverse whole every element or every node in this linked list. Okay. Now this is the data part, and the reference of this node is null because it is not pointing to any other node. So this is what we mean by linear fashion. Now again, you can only store homogeneous element. That means you cannot store different types, data types of element in this linked list as well. So similarity is there. Now one more thing is the drawback was there, the size was fixed in arrays. Here, as you can see, you can easily add or remove or do anything with your nodes. The size is not fixed, the size is dynamic in nature, and we can easily insert and delete. We will see how we can insert the elements. Okay, sir, first node is a head node, or we have to create a new head node separately for the linked list? No, you can simply what you do, you create this first node and you just store that reference in this head node. I will show you how. Okay, so the head node, the first node is your head node. Okay, so you don't have to explicitly create a different node or a dummy node. Okay, so easy insertion and deletion. Now in arrays we need to swap. Here no swapping is required. You just have to you have to just change the links. That's it. You just have to I will show you, just by changing or just by manipulating a single link you can insert or delete your elements. Okay, is that clear? Okay, great. Now the last thing, that's the starting element or the node, that is the first node, is termed as your head node, which I already explained. Okay, so now let's talk about some advantages and a little bit disadvantages, then we will see the implementation. Okay, so first is that it is dynamic in size, which is quite obvious that in arrays we used to have that size fixed and we cannot exceed that size. But if we are not exceeding that size, if we are underutilizing that, we are storing only 2 elements and the size is 4, that means again we are we are underutilizing our memory. Okay, no wastage of capacity and size is equal. Basically whatever is the size of the linked list is the capacity that it holds. That means there is no wastage of memory. Insertion and deletion is possible and you have to manipulate only single link. Let me give you a brief diagrammatical representation of this insertion and deletion. So okay, okay, one second. Let me just clear it out again. So let me just create it again. So you have these nodes. Okay, this is nothing but I am pointing these nodes. Okay, you have these 4 nodes. Let's suppose there it's 10 in it, 20, 30 and 40. Now the next part will contain what? Addresses. Let's suppose this is 1000. This is your head node. Okay, this is, let's suppose this is 2000, this is 3000 for simplicity. Okay, so now this will contain the reference of this node, which is 2000. This will contain the reference of this, which is 3000. This will contain the reference of this, which is 4000, and this is null. Now if I want to delete an element, let's suppose I am trying to delete this element. Now simply what I have to do, without any swapping, so this arrow points to this, without any swapping, what I will do, I will just, whatever is in this, whatever is in the next of this node, I will just simply place it over here, and that means this is now pointing to this node. Okay, simple. Only by manipulating a single link. That means this link was changed to this. That's it. Now I can also remove this and then I can free this, but once this is removed, this link is removed, the garbage collector will take care of this. That is the beauty of Java. Okay, done. But what if I'm trying to insert an element? Let me just erase all of these things. Okay, so now what I will do, now let me just choose a different color over here. Okay, so now when I want to insert this node, let's suppose this is 60 and I want to insert this at, let's suppose, this particular position. Now what I have to do, Simply, I will just, whatever is in this node, right? Let me just erase this thing as well. Okay, so since this is pointing to this, okay, so what I will do, I will simply make this node point to this. Let's suppose that there will be some address associated with it. Okay, let me just clear it out again. So there will be some address, that is this is 3000. Let's suppose this is 5000. There will be some address associated with this particular memory. So what I will do, I will simply update this. I will update this and I will make this point to this node. Right now this is pointing to this node. Now in this node, what I will do, I will just make this node point to this node, which is nothing but 3000. Now if I write this thing over again, I don't have to change this thing. Okay, so if I write this thing over here again, or with a new node inserted, simply what has happened, 10, 20, and you have 30, not 30, then you have 60, then you have 30, because 30 is pointing to 4000, right, which is this, and this is 3000, and this is pointing to 3000, which is over here, which is 5000. This is pointing to this 3000. This is pointing, this is the address of this is 2000, and it is pointing to this 5000, which is this. Okay, so just by manipulating a single link over here, I am just simply manipulating this link. Okay, here I am just simply pointing this node to this. There I'm not manipulating it. This is the new node, so I'm just updating that. So manipulation is again a single link. Now no swapping is required. Now we will, as we go along with this session, and as we understand linked list more and more in detail, you will be able to understand how we can make this deletion operation and how we can make this insertion operation. So in over here, if I'm talking about the diagrammatical representation, it is only the manipulation of one single link. Okay, and efficiently you are using your memory. Okay, now what about the disadvantages? If your head is lost, that means the first node which is pointing to your head node, the first node which is obviously your head node, if you have lost this, or if you have manipulated this node, the whole linked list will be lost. Okay, that is, every time whenever you see the program which is written in linked list, or wherein you have implemented linked list, you keep this thing in mind that you will not lose your head node. Okay, and no random access is possible, because it is with the help of this head node you will traverse the linked list. So every time when we are trying to traverse, we simply, what we will do, we'll use a temporary node type, temporary variable which is of type node, and then store this head in it, so that this is not manipulated. Okay, so this is the trick, or this is the standard that we follow, so that this head node is not manipulated and we can easily traverse through the linked list. Okay, so let me just show you how, what is this node, what is exactly this node. Okay guys, so quickly confirm, and then we will try to understand what is the, how we can implement this, a little bit understanding of that, what is a node and how we insert it. Quickly just write a yes or no in the chat. Quickly guys, we are about to end this session, and we have already wasted a lot of time. Quickly just write a yes, no in the chat, that if you were able to understand the diagrammatical representation. Don't worry about the slides will be shared with you, so don't worry about it. It will be there on our YouTube, the live sessions, along with that will be the link for this slide deck. Okay, cool guys. So now let's continue. So the node, right, I was talking about this node. So we have this class over here which is linked list node. Now the structure of this node is that it will be having one integer data type, which is your data part, and one is the self-referencing. So there's another node, another element which is of type node, so that we can store that reference over here. So the next, okay, so it will be here like this. This is the structure of the node. It will have two parts. One is the data part, and another is known as the next. Why it is of type linked list? Because we are referring to this node right over here. You see, the next it will be pointing will be again of type node, which is of this same. Okay, so this is the reference that you're pointing to. So this is the structure of your node. Now there's one constructor that every time when you're trying to create a node, so you have these default values associated with it. So it is a parameterized constructor. So whatever is in the data will be over here. Let's suppose you are passing at the time of creation, you're passing 5. So 5 will be in the data part, and every time when you're creating a new node, it will be null. Sir, what does this mean? This is basically a keyword which means that it is pointing to that current state of that object. Okay, so this dot name, that whatever you are passing, so that usually what happens when you have over here, let me just clear this thing. So now let me just clear whole screen over here. Now let me just write it. So here, as you can see, the argument is also of type, the argument I have named data, and the class over here, in that I have this data member which is again data. Now our compiler, or the just-in-time compiler that we are using, the JIT basically we are using in Java, so he should not be confused what is this data and what is this data. So here what I meant, whatever is the current object data, whatever is the current object's data, it refers to the current state of the object. So this means that we are referring to this object that is there, which is of type data. This is that type of data, and this is the argument that we are passing. So that is why we are using this. So this is also used to avoid name collision. So as you can see over here, name collision. What do you mean by this thing? That as you can see over here, there is this data and this is data. So basically you are using two data. If you remove this, then it will throw you an error. It will say that you are trying to assign same thing to the same thing. So name collision is there. To avoid name collision, you can use this, and you can apply this thing to all the things, right? Even in constructors, in your functions, in your variables, you can assign, you can use this keyword to everything. Okay, so here over here I'm trying to avoid this name collision. If you don't want to use this, it is okay, but it is recommended. But then you have to just remove this data over here, just write int d, and that's it. Write d over here, remove this part, and write next is equivalent to null. Okay, if but it is recommended. Okay, so that is why. And we want to use this, that we are assigning this data to the data part and next to the null part. So that is why, for that we are using this keyword. Okay, done. Now what about the insertion at the beginning of the node? Okay, so now let's try to there are two scenarios. Let's suppose first scenario is that there is no node, you don't have any nodes yet. The second thing is that when you have at least one or more than one nodes. That's it. Two cases. Okay. Now let's try to visualize these two cases. So let's suppose when you have no nodes, then this head will be null. Obviously you don't have any nodes. And let's suppose we are passing in the key as 5. Now when the first scenario is there, that means there are no nodes. That means you are creating one new node over here and you're passing this key. Now what happens over here? Your constructor will be called, which we just saw. This constructor will be called, right? And now you will be creating one node which will have 5 as in data part, because this is the key. 5 in the data part, and this part will contain null. Why? Because of the constructor. Done. This step is done. Now since our head is null, that means we don't have any nodes. We don't have any nodes yet. So that is why this is the first case. Okay, so now what we are doing, we are pointing this head to this particular node. Obviously this will have some address or reference, so this is pointing to your head. Okay, that means head will have this 1000 as the reference. Okay, this is the first time. The else will not be executed, you will return the head, which is obviously of type linked list node. Now next time again you are trying to insert one more element or one more node in your linked list. Now next time, obviously now this time around, this will be the scenario. Now this time around, the head is not null, it will be 1000, and the element that you're trying to insert is 10. Okay, again you are creating a new node with the help of this step over here, and again you will be creating a node which is something like this. You are passing in 10 and this will be null. Why? Because of the constructor. Done. And you are allocating memory. Now this time around, head is not null, it is 1000. So this if block will not be executed. Now what about this? What about this else part? What you are saying ttmp, that is the temporary node, that is, this is also ttmp. right? This is also your temp node, right? This is the reference, and let's suppose here you have 2000, okay, the address. That is your, the basically what is this, this is the reference. Basically this head node is pointing to this, that is your reference will be stored somewhere around here, okay? So for simplicity I'm saying that 1000 will be stored in head, so it will be a hexadecimal number, the reference, okay? Now let's go back, right? And yeah, so now what I'm saying, ttmp is next. What is ttmp is next? That means we are talking about this node, this particular position. ttmp is next. This, we are saying insert head into it, so head is pointing to 1000, so we are inserting 1000 in it. That means this is pointing to this node. Now you are implementing insertion at the beginning, so every time your head will change because you are inserting your element at the beginning. So now what the next step is, that you will update your head. Now you will say whatever is the ttmp pointing, make this head also point to that node, so head will be pointing also to this node because this is your head node now. So every time your head will change, so this is done, and then you return the head node, okay? Done. Okay, so this is how you insert every time the node at the beginning of the linked list. Okay, done. So now we are done with this. Now we have exhausted our 1 hour. So what you can do, guys, I have already sessions created in Java. Okay, and we have implemented this data structures and algorithms in Java. So we have a 10 hour, around 10 hour is the length of the course. You can check it, it is on our YouTube channel. And in order to get the completion certificate of any of the data structure related programs, okay, you can check those as well. Okay, is this clear? So whatever is missing, whatever you have the questions, how do you insert at beginning, how do you insert at end, everything in detail is explained. Okay, correct? So you can go through that video. If you are comfortable with this live session, you can revise this live session, and whatever is already taught, just skip that portion from that particular course, which is a 10-hour course. Okay, so learning programming is necessary for AI. Yes, Sabha, everything, your programming language is important, very important. Okay, okay, so you can go through that 10-hour course. Okay, and if you want a certificate, the completion certificate, you go visit our website, go visit our Great Learning Academy and register yourself and get your completion certificate. Okay, cool. So thank you so much, guys, and I'm so sorry for that. When my system crashed, you were waiting, and I hope you enjoyed this session. And all the very best, and stay safe. And thank you so much, guys. Take care.